So for this one, we have, A is going downwards and B is going that way. Okay. And then here is theta. And so it's saying at what rate is the angle theta changing as it relates to A and B. All right, so the key players here are A, B, and theta. So now I need to come up with an expression or an equation that has A, B, and theta. And if it's capital, let's just be consistent with the capitals here, A and B. Yeah.
Like, I think I got the equation as in like tangent theta equals A over B.
Right.
I just like from there I got
Okay, so tangent of theta is equal to A over B. Now, I have to take a derivative of both sides of this with respect to t. Okay, so the derivative of tangent is secant squared theta. And then I get d theta dt.
Right, yeah.
Okay. Equals, here, I have to do quotient rule. Yeah. That works too. Or you could do AB to the -1 and do product rule. Either will work. Okay? So here, if we do quotient rule, it's B times dA dt minus A dB dt. All over B squared. Right? And now we have to put in all of the information that we have. So take a look at here. A approaches the intersection at 2 meters per second. That means dA dt is what? Is it positive or negative 2? So it's negative 2 because it's decreasing, right? Meters per second. And then dB dt is 1 meter per second. And it says all this is happening, and so when A is 10 and B is 20, when A is 10 and B is equal to 20, we need to find d theta dt. So, what did I do? I haven't done anything with anything yet. I'm now going to put everything in.
Oh, I thought you were done.
Yeah, now I'm going to put everything in. So, okay, so what do I have here? D theta dt is what I'm looking for, right? Now, let's look at everything else. I have B here. I'm given B, dB dt, dA dt, A and B. I'm given all of that. Here, I'll tell you right now. Here, I'm missing a theta, right? So now I need to use A and B and figure out theta, all right? How do we figure out theta? Tangent of theta is, what did we say here? A over B, right? That's 10 over 20. Yeah, so for what angle, right? If tangent of theta is 10 over 20, then what's the secant of theta? Is it? That's the cosine, right? So if I write it this way, so if this is theta, and if tangent is 10 over 20, how am I going to find secant? What is the secant here? Secant is 1 over the cosine, right? So it's the hypotenuse over the 20. So how would I find the hypotenuse over the 20 here? Right. Okay? So secant of theta is 1 over root 5. No, it's root 5 over 1. Then you have to find the secant of that.
secant is the inverse of cosine, so if we find a cosine is from tangent.
But can you use what time what theta is and then plug that in?
You can do that too, right? But how would you do it? Would you do it? What would inverse tangent be?
Theta equals tan inverse 10 over 20.
Right, and then you would need like a calculator to do it, right?
Yeah.
Right, but if you don't have one, then we have to figure out another way to do it. Okay? So d theta dt is equal to all of this, so negative 40 minus 10, negative 50 over 20 squared times 1 over root 5. Okay? 36. So 36. If the radius of a circle is expanding at a constant rate, then its circumference is increasing at a constant rate. So what's the circumference? It's 2 pi r. Oh. So the circumference is 2 pi r. So now when I do the rate of change of the circumference, right? It's 2 pi dr dt, correct? But now it's telling you that the radius is expanding at a constant rate. That means it's telling you that dr dt is a constant, right? So if this is a constant, then this whole thing is a constant. So dc dt is also a constant. Okay? Other questions? For 19C, right, how would you set up the equation? It would be...
Tan theta equals y graph.
Right, you can do any one. You could do tangent, you can do cosine. Okay, because that's a constant as well, right? Like the 13 is a constant. So if you were to do cosine of theta is 13 over, no, sorry, x over 13, okay? Negative sine theta d theta dt is 1 over 13 dx dt, okay? And then, same situation, this is all happening when x is equal to 12, okay? So if it's 12 and 13, then you have to find, you know, the sine of theta and you have to put it in. Okay? So a man 6 feet tall walks at a rate of 5 feet per second toward a street light that is 16 feet above the ground. At what rate is the length of his shadow changing when he is 10 feet from the base of the light? Right? So this is exactly like the one that we did in the homework. And you kind of have a picture here for number 30, but you could also use it for number 29, right?
Like when I was looking at the equation though,
Yeah.
like, where is that?
So that's the lamp, right? Right there. And so suppose the guy is over here. That's his height. Okay? How tall is he? He's 6 feet tall. And the street light is 16 feet above the ground. And so remember, like last time we had said, you know, this is X and this is his shadow, right? Should we do B? Okay. So now how are we going to set up this equation? So basically it's going to be a similar triangles where you have 16 over x plus b is equal to 6 over b. Oh, and now we have 6's and b's. Before it was 5's and s's, now it's 6's and b's. Okay? And so 16b is equal to 6x plus 6b. Oh my God, I really didn't choose this variable wisely. Okay? So 6x is equal to 10b. Yeah?
Yeah, I got that.
Uh-huh.
And then you take the derivative.
Uh-huh. So what do you get when you take the derivative?
6 dq dt equals 10 dx dt.
Right. So 10 dB dt
Oh, yeah.
is equal to 6 dx dt. Okay, then what? Okay, so what would we plug in here? He is walking, so the man is walking at a rate of 5 feet per second. Which one is that? That's dx dt in here, but is it positive or negative 5?
Oh, it's negative.
Negative because it's getting smaller. 10 dB dt. So dB dt, oh my gosh, it's now d's and b's. Okay, it's negative 30 over 10, which is negative 3 feet per second. Okay? Other questions? Anybody else have any other questions? No? All right. Any other questions from 4.4 or 4.5? All right, so first we have a rectangle that is supposed to be inscribed under the curve, the square root of 16 minus x squared. So we talked about this last time, and we said when I have the square root of a constant minus x squared, that is a semicircle, all right? And the square root of that number is the radius. So here we have a radius of 4. So that's what that looks like. And if it was negative root 16 minus x squared, then it would have been the semicircle underneath. So now a rectangle is supposed to be inscribed here, and on purpose I don't do it on the corners, right? Like I do it between the lines so that we know that this is an arbitrary length here. What are the dimensions of the rectangle with the largest area? If I need largest area, that means I need to write an equation for the area. And I know that area is base times height. Now, in here, this is x, so the entire base is 2x. And then the height is y, which in this case is the square root of 16 minus x squared. So that is a of x. Okay? Okay. Now, I need to find the derivative, a prime. So to do that, it's, this times the derivative of the second. So 2x times the derivative of the root, 1/2 will come down, and it's 16 minus x squared to the negative 1/2 plus 2 times the root.
Wait, why is the height root 16 minus x squared?
Don't you also have to take the derivative on the inside, so it's also...
Oh, yes, I do. Because it's the derivative, because it's the height, the length. The height is y, okay? And depending on where you are here, your y is different lengths. And it changes like this equation. So here, this is also times 2x times negative 2x. And then plus that, right? Okay, so this 2 will cancel. So a prime of x is equal to, I have negative 2x squared, 16 minus x squared to the negative 1/2, plus 2, 16 minus x squared to the 1/2. I can factor out negative 2, 60 minus x squared to the negative 1/2. And I get x squared minus 16 minus x squared. Okay? So this is negative 2 times, from the bracket, I get 2x squared minus 16 over the square root. Okay? The domain here, oh, sorry, we never wrote the domain. The domain is from 0 to 4, right? So from here, my critical points, so this will give me, like the denominator will give me plus or minus 4, but that can't be included, right? So from the top, I get 2x squared equals 16. X squared is 8. X is plus or minus root 2. So I only take 2 root 2 as my critical point. Okay, now, what are the dimensions it says? So x is 2 root 2, right? So that means my base is 4 root 2 because it's 2x. And my height is the square root of 16 minus x squared, which is 4 times 2 is 8, which is the square root of 8. So h is 2 root 2. Okay? Questions?
Why is the base 4?
Because it's 2x. Right? X is only half the base.
How do you get that?
Yes, so the area the area is going to be 2 root 2 times 4 root 2, 16. Okay, so we have to approximate the cube root of 65 by using a linearization centered at the appropriate nearby number, right? And what's that nearby number going to be? 64 for this one. Okay, so we have to write the linearization. So f of x is going to be what? It's going to be cube root of x, right? So what's f prime of x going to be? Negative 2 over 3, right? Okay. And then what else do we need to do here? Uh-huh. And how much is that? So, to the power of, oh my gosh. Which is 1 over 3 cube root of 64 to the power of 2, right? So that's how much? 1 over 3. What's cube root of 64? 4 squared is 16. Okay. So how much is this here on the bottom? 1 over 48. Okay, so what else do I need? So what's my linearization now? I also need f of 64. And that's just the cube root of 64, which is 4. So tell me L of x. What is it? Uh-huh. 4 plus, right, the slope times x minus 64. Okay? And so now, what's L of 65? times 1. Okay, so that's 4, 1 over 48. Okay? All right. Next one. You have g of 5, g prime of 5, and then g double prime of 5. And so here, we need the linearization again, right? So the linearization is basically our y minus, it's my point slope form, right? Y minus y1 equals mx minus x1. So that g double prime, that's extra information that we don't even need. All right? So, what's going to be the approximation here? So Marsha flies a kite at a height of 100 feet, and the wind carries the kite horizontally away at a rate of 15 feet per second. How fast must she let out the string when the kite is 200 feet away from her? Okay, so basically, you know, here's the kite, okay, and it's 100 feet above the ground. Okay, and here's, you know, this person standing here. Okay, the wind carries the kite horizontally away at a rate of 15 feet per second. And so how fast must she let out the string? So this is the string that she's holding right here. When the kite is 200 feet away from her. So this is the 200 feet. Okay? Huh? No, that's the kite.
So
One's a stick figure,
wait,
one's a diamond.
So the other leg
She's levitating in this.
No problem. Uh-huh. Because, okay, so if the kite was on the floor, then it would, you know, then it would be 200 feet away from her horizontally. But the kite is in midair, and so the direct distance between her and the kite is that horizontal distance, okay? All right, so one thing here, hang on, one thing here is constant, and that's the y, correct? So here I can put in the y immediately. So it's 100 squared is equal to z squared. Now, when I take a derivative, 2x dx dt plus the derivative of 100 squared is 0 is equal to 2z dz dt. Okay, so what happens if you don't put in the 100 in the beginning? Then you're just going to get 2y dy dt. But because y is staying level, dy dt would be 0, so that term would again go to 0. Okay? I know. Okay, so now this is so what's dx dt? It's the wind carries the kite horizontally away at a rate of 15 feet per second. So that's dx dt. But I don't have x. How am I going to find x when z is 100, right? And, no, I'm sorry. Z is 200 and y is 100. You do the Pythagorean theorem and you get that x is equal to 173.2. Okay? So this is going to be 2 times 173.2 times dx dt, which is 15. Because it's moving away, it's increasing. It equals to 2 times 200 times dz dt. The 2's will go away, so dz dt is 12.99. So the answer will be 12.99 feet
If I left it in
per second at a rate of 20 cubic centimeters per second. So from that, you know that that's dv dt, right? Because centimeters cubed is volume. So that's dv dt. How fast is the surface area increasing when the radius is 30 centimeters. Oh, well, it didn't do anything anyway. Okay. All right. So we're given volume, so let's start with volume. All right. And now this is dV dt. So let's find dV dt here. This is 4 over 3 pi times 3 r squared dr dt. The 3's will cancel. So dV dt is 20. And this is equal to 4 pi times the radius is 30 squared dr dt. Okay, so first I need to find dr dt, because when I take a derivative of surface area, I have to put dr dt in there. So now dr dt is 1 over 180 pi. And leave it in terms of pi for the beginning. Okay, now I need the rate at which the surface area is increasing. So how fast is that increasing? Well, let's start with S equals 4 pi r squared, right? ds dt is equal to 8 pi r dr dt.
Will you give us all the formulas with that? Like S equals 4 pi r.
That you should know, right?
What if
So,
I
huh?
What if I don't know that?
Surface area.
Yeah, I don't remember the surface area for
Okay, let me finish this one.
It's like the surface area is 4 pi. I thought it was like, isn't it just a circle that's pi?
That's a circle, but the surface area of a sphere. Let me finish this and then I'll go over it. So ds dt is equal to 8 pi times 30 times 1 over 180 pi, and then at the end of the day, we get 4 over 3. So how fast is the surface area increasing? ds dt is 4 over 3 centimeters squared per second. Okay? All right. So,
Oh, so these just two circles. Is that why?
Hmm?
Is it these, there's this and this on the surface?
no, it's a sphere. It's a spherical balloon, like a ball. It's not a cylinder, it's a spherical balloon. It's a perfect sphere. So, the sphere, all right, so the sphere is the only shape where, look at this. So, what's the volume of a sphere? 4 over 3 pi r cubed. And now if you take a derivative of that with respect to r, just take a derivative of this with respect to r, it will be 4 over, so if we did like dv dr, it would be 4 over 3 pi times 3r squared. Okay, and because it's with respect to r, we don't do dr, that's just 1. And so what is that? 4 pi r squared, and that happens to be the surface area.
No.
I know.
That's actually.
Okay, that happens to be the surface area. So when you take derivatives, what you end up doing, we find out later, is you strip away dimensions. So you have length, then area, then volume, right? And then if you go the other way, you have volume, then area, then length.
Oh, it's like motion graph.
So if you keep taking a derivative, you take away dimensions. So you go from volume to area to like a unit of length. Now, if you take a derivative of this, it's 8 pi r, right? Which is a factor away from 2 pi r, the circumference, right? Huh?